Good evening. So today we are starting with Poisson distribution. So last time around we dealt with binomial distribution. So today we continue with Poisson distribution and move on to hypergeometric distribution, right? So I saying when the total number of possible outcomes cannot be determined, we cannot use what? Binomial distribution. We can only use binomial distribution only when the possible outcomes can be determined. So for example, when we can count the number of potholes per mile, but we cannot count the number of non-potholes. In such situations, we need a different kind of probability distribution to describe such phenomena. So let's look at the characteristics of Poisson distribution. So we are saying the outcomes of interest are real relative to the possible outcomes. The average number of outcomes of interest per unit time or space interval is lambda this time. I'm saying mean number of occurrences in an interval t is mu is equal to lambda times what t. So you can be given the average number of outcomes of interest per unit time or space interval. That is the lambda. And the time, that's the t. So when you are looking for the mu, you just multiply the lambda and the what? T. All right. So the number of outcomes of interest are random, and the occurrences of one outcome does not influence the chances of another outcome of what interest. So it's more like the mutually exclusive. You get it? The probability that an outcome of interest occurs in a given segment is the same for all segments, right? So with this one, we are just reading about reading the characteristics. We move on to the working soon. Okay, so this is the formula for Poisson distribution. So this is a lambda times t raised to the power x times e, and we know e from natural log. You get it? It's a constant something. I think it will give you 2.71828 or something. I've forgotten the exact figures. Right? Raise power negative lambda times t. And we also know that lambda times t will give you what? Mu. That's the u here. So the lambda times t will give you mu raised to the power x times e raised to the power negative lambda times t will also give you mu. So mu raised to the power s times e is a natural log raised to the power what? Negative mu all over x factorial. All right. So let's define them here. So we are saying t, we all know t from what I read previously. We are saying t is the size of segment of interest. That's the time in the question. You get it? X is the number of successes in a segment of interest. Lambda, the expected number of successes in a segment of unit size. So the expected number of successes in the time. You get it? Example, you are saying 1 hour. So as I said, mu is the mean number of what? Mu is the mean number of occurrences in an interval. So the mu is calculated by multiplying lambda by t or time. So the example is here. If mu is 20 per every 2 hours, then t is 2 hours, and lambda is what? 10 per hour. This is the e. Okay, that's the figure. This is a constant number. So we just input it here. So let's look at the example below, right? So we are saying a study conducted at Whole Foods grocery shows that the average number of arrivals at the checkout session of the store per hour is what? 16. So this becomes our what? Average expected something, which is a lambda. Further, the distribution for the number of arrivals is considered to be Poisson distributed. What is the probability of X? So X here is what? 12. You get it? X here is 12. Number of customers arriving at the checkout in 1 hour. So our T becomes what? 1 hour. You get it? So when you are looking for the mu, is what? Lambda. Okay. Lambda times what? T will give you the mu. So the lambda I said is what? 16 here times time or T. 1 hour is here. That will give you what? 16. So we are looking for the probability that X is equal to 12 of customers arriving at the checkout in 1 hour. You get it? So we are saying the formula is P of 6. X is 12. So P of 12 will be given by. And who can tell me the formula? We are saying is mu raised to the power X. Mu raised to the power X. So the mu is 16 raised to the power X. X is what? 12, right? Times E. We all know E, right? Raised to the power negative mu, negative 16. Sorry, I'm using mouse. All over X factorial. That is 12 factorial. Come on, let me write it 12. So that's the working here. I cannot write it, so you take it like that. So that's the working here. So mu raised to the power X E exponent negative mu all over X factorial. So as I said, the mu is what? 16. Multiplying lambda by time. Raised to the power X. X here is 12. Yeah. You get it? Times E. E, when you punch it on the calculator, you get 2.71828. Raised to the power negative mu. The mu is 16, so negative 16 all over X factorial. X is what? 12. So 12 factorial. So your probability will be 0.0661, right? So this we are just doing a recap. So let's look at another question here. So using the Poisson probability function, patients arrive at the emergency room of Mercy Hospital at the average rate of 6 per hour on weekend evening. So 6 here will be what? What's the 6 here? What does the 6 stand for? The moment you see average rate per sessions. So you see that this 6 here is our lambda. You get it? What is the probability of 4 arrivals? So our X becomes what? 4. In 30 minutes. Here the T is what? 30 minutes time on a weekend evening. So normally, if it is in minutes, we convert it to what? Into hours. Because the lambda here is 6 per hour. So when you convert that one into minutes, that one will be like tedious work. So you just convert the 30 minutes to what? Hours. So the 30 minutes will give you what? 0.5 hour. You get it? So to calculate for your mu, it will be mu is equal to the lambda is what? 6 times time. Time here is 30 minutes, so it will be half an hour. So times 0.5 or times 1/2. That will give you what? 3. So here your mu will be what? 3. So the probability of 4 will be equal to I'm waiting. Someone should just mention it for me. I want to see if you are really I'm waiting. I want to see if you are really following what you are doing. Someone should talk. We know our lambda to be 6.
So get 13.49.
13.49. Okay, we want to go by like step by step. We want to follow step by step. So we want to use the formula for Poisson. You get it? So can you help us?
So it will be 3 exponent 4 minus e negative and exponent negative 3 all over 3 factorial. It's 4 factorial, sorry.
Okay, so who is giving me the answer?
3.37.
3 point. This one is probability. You guys should help me out. I'm not having a calculator here. So 3 raised to
0.16.
0.16. Okay. Okay, so this was the answer. All right. So the Poisson is not difficult. All right. So let's be quick and move on to today's topic. Because today I'm treating normal distribution and standard normal distribution. This Poisson was just a recap. You get it. So this is our lambda 6. So you're going to see average rate per hour, like your average expected something within the segment. So 6 per hour. So that becomes your lambda. And your time is the t. You get it. So here they are saying arrivals in 30 minutes. So you have to convert it into what? Hours. You get it, because we are having 6 per hour. So when you convert this 6 into minutes, you suffer. So you convert this 30 minutes into hours. That is one, you get 0.5. So to find your mu is lambda times t. So 6 times half will give you a 3. 3 per 30 minutes. You get it, right? So we know the formula to be mu raised to the power x multiplying y. So the y, when you point it on the calculator, that's what you get. Raised to the power negative mu all over what? X factorial. That one should give you the probability under the Poisson. So this is the mean, variance, standard deviation here, right? So you can use the Poisson tables as well, right? So let's move on to the hypergeometric distribution. So is it okay? Can I continue? I want to move on to hypergeometric. I'm moving fast because today this one is not our main focus. Any question for me? Can I move on? Yes.
You see, where you said you have to, what is the name? Change it to hours. That you had half, the 0.5.
Okay.
That place I'm a little confused. How do you do it? You see, you said arise in 30 minutes on a weekend evening. And you said that 30 minutes is the time.
Yeah, it's the time.
Yes, and then you say you have to change it to hours.
Because the lambda, you see, for you to be able to find a mu, that's the mean. You get it? You multiply lambda by what? Time. So here the lambda is what? 6. And the 6 is in what? In hours. Because it says per hour. And what is the probability of 4 arrivals in what? 30 minutes on a weekend evening. So this one is in minutes. This one is in what? Hours. So you have to convert this 30 minutes into hours before you work to find your meal. Because you cannot multiply hours by minutes. It has to be minutes multiplied by another minute or hour by hour. You get it? You get it?
Yeah, I get it.
Okay. So any question now? Can I move on?
Yes, please.
All right. So let's move on to the hypergeometric. Now we are saying with this distribution, within a trial, there should be 2 possible outcomes per trial. I repeat myself, within a trial, within one trial, there should be 2 possible outcomes per trial. So n trials in a sample taken from a finite population of size n. So this one deals with the population and the sample. You get it? Sample taken without replacement. Trials are dependent. So this one is not mutually exclusive. You get it? Concerned with finding the probability of x successes in the sample where there are capital X successes in the population. So this is the formula as well. So as I said, 2 possible outcomes per trial. Within a trial, there should be 2 possible outcomes per trial. So this is the formula. You get it? So this one is a combination. Combination big N minus small big S here. The subscript is small n minus small x multiplying combination big X, small x here, all over combinations, big N over what? Small n. Do you get it? So this is the what? Definition of the formula. You get it? So you are saying where n here, the big N is population size. So the population size is represented by what? Big N. The big X is what? Defined by a number of successes in the population. Small n is what? The sample size. So as I said, it deals with population and what? A sample. X is the number of successes in the sample. N minus X gives us, as we know from binomial, it gives us what? Number of failures in the sample. So let's look at certain example here. Example. So we are saying 3 light bulbs were selected from 10. So the 3 light bulbs were selected from 10. So meaning 10 is the overall population. You get it, the overall population. And the 3 were the sample. You get it? The 3 were the sample. So 3 light bulbs were selected from 10. There were 10 bulbs and they selected 3 out of the 10. You get it? So the 10 here becomes the big N. The 3 here becomes what? The small n. Of the 10, there were 4 defective. So here, defective is our concern. So defective is our what? Interest. So defective becomes a success for us in this type of question. You get it? So of the 10, there were 4 defective. Meaning the 4 here is our big X. Big S is what? Number of successes in the population. So out of the 10, there were 4 bulbs defective. And by now I know you know the meaning of defective, right? What is the probability that 2 of the 3 selected are defective? So the 2 here will also represent what? Small x. That is the number of successes in the sample. So look at something here. So the n deals with the population. The 10 here deals with the population. 4 here deals with the population. 3 here deals with what? the sample, and the 2 here also deals with the sample. So 10 here is big N, 4 here is big X, 3 here is what? Big X, and 2 here is what? No, so I'm counting. 3 is small n, x, small x is what? 2. And the defective, out of the 10, the 4 defective is the what? Big X, because that was the successes in the population. So we have successes in the population, successes in the sample, and we have population size, sample size. So the sample size is the what? 3. Sorry, the sample size is the 3. Yes, that's the 3 bulbs were selected. And the overall population, the number of bulbs, the total number of bulbs were 10. That's the big N. And the successes in the population, that's the 4. There were 4 defective. That one becomes your big X. And what's the probability that 2 of the 3 selected are defective? So the 2 here becomes your what? Small x. You get it? Then you use it to, like, you substitute this info into the formula here. So the formula we are saying we have, so the x becomes 2. So we are dealing with the small x. We are saying that C, the combination n minus x. So the big N minus big X. So 10 minus 4 will give us what? 6. Then small n minus x. So 3 minus 2 also give us 1. So we have combination 6, 1. Times combination x, big X is what? 4. Then superscript 2, that's the small x here. All over C, that's the combination big N and small n. Big N is what? 10, small n is what? 3. I know by now you know how to punch this combination on the calculator. You get it? So
No, please.
he said no.
Yes.
It's shift plus the division sign. Who is having a calculator? Try it for me.
Yeah, please, you can continue. Shift
Okay.
plus division sign and what again?
So the superscript, you type the superscript first. So to be 6 combination on the laptop, on the calculator, then 1. You get it? Multiplied by the 4 superscript 1, 4 combination 2, all over the superscript 1, 10 combination, then subscript, that will be 3. So punch this one, you get 0.3. Who's confirming it for me?
Yeah, I'm doing that. Yeah. You get 0.3.
Okay, 0.3, thank you. So this is hypergeometric distribution. So far we've learned binomial distribution, Poisson distribution, hypergeometric distribution. Then we are moving on to today's topic. That is a normal distribution. So that one we have normal and standard normal distribution. You get it? So any question for me, like under this Poisson and hypergeometric, before I move on to the today's topic, that is a normal distribution and standard normal distribution. So let me repeat this one again. So the hypergeometric, it deals with what? A population and what? A sample. You get it? A population and sample. where the big N represent the sample population size, small n represent the sample size, big X represent the number of successes in the population, small x represent the number of successes in the sample. Then small n minus small x represent the number of failures in what? The sample. So the important thing is to know these things here. You get it? Then the formula is this. Formula is here. Any question before we move on to the normal distribution? Okay, so let's continue. So we are saying with this one, with the normal distribution, okay, let me read this one. Most phenomenon in life, including weight, shoe size, and height of humans, are modeled using the normal distribution. The normal distribution is also at the heart of parametric statistical tests, including hypothesis, ANOVA, and simple linear regression. You get it? So that's another distribution under probability. So these are the session goals. Probability distribution. So the normal distribution, you should be able to standardize how to convert a normal distribution or a normal distributed value, random value, variable, that is x value to what? Z value. So the process of converting x value into z value is called what? Standardization. Calculate probabilities from a standard normal distribution using the normal tables, the standard normal tables. You get it? All right. So let's move on. So the normal distribution. So this is the curve, right? So we are saying it is bell-shaped. So this is the curve, bell-shaped. So it is symmetrical, and I hope you know the meaning of symmetrical. You get it? Whatever is here on the left side is equal to whatever is here on the right side. So the mean here, that's the mean here, is equal to the median, mode. They are equal. So median, mode, and mean are equal. The location is determined by what? The mean. Spread is determined by what? The standard deviation. Then the random variable has an infinite theoretical range. So it is moving from what? The positive infinity to what? The negative infinity. You get it? Right. Okay, so let me illustrate something here. So let me draw the curve. All right, sorry. So this is the curve, right? Sorry, I'm using the mouse, so take it like that. This curve is not. Let me draw it again. Okay. All right. Okay, so it is symmetrical. You get it? So the mu is here, and the SD, that's the standard deviation, is also here. So sigma. All right, so this is the curve. So we are saying, let's say, after writing exams, Come on. No, it's not easy. So after writing exams, let's say most of the students scoring the average marks will be here. You get it? 50, 60, 65, they will be in the middle here. And few of the students failing will also be here. And few of the students passing will also be here. You get it? So at times, the normal distribution, in the middle, you find like many people. You get it? And the left tail, you see smaller people or a few people. At the right tail, too, you see what few people as well. You get it? So at the end of the exams, and you see a lot of people having A's. You get it? So to be few people failing, and more people what pass. You get this is why it's will look like. You get it? So this one, the tail is moving towards the negative direction. It's moving on to the negative direction. So we call this one negatively skewed distribution. And the opposite is what? When a lot of people are failing. So a lot of people are failing, only few are passing. This one to the tail is moving to the what? Right. This one will be the positively skewed distribution, and this one will be what? Negatively skewed distribution. You get it? All right. So this is a basic explanation on the curve. So let's move on to the slide. So we are saying that shifting the mean shift the distribution left or right. So when you decide to change the value of the mean, it feels like you are shifting the curve from one location to another without expanding it. You get it? So when you change the value of the mean, you are shifting the curve from one place to another. The same thing applies to when you change the SD or the sigma, that's the standard deviation. It increases or decreases the spread. So let's look at this example. So you see that this one, the green one and the yellow one here, they are not the same, but they are having the same mu. You get it? They are having the same mu. They are having the same mu. You get it? But one is what? Taller than the other. The yellow one is taller than the green one. Look at the purple, or I don't know if it is pink or something. That one too is having different mu. You get it? So by varying the parameters mu and standard deviation, we obtain different normal distribution. That one too is a basic knowledge or something. So let's move on. The important thing is there, right? So let's move on to finding normal probabilities. Finding normal probabilities. So probability is measured by the area under the curve. So this is the area under the curve. You get it? So we are saying probability is measured by the area under the curve. So I hope when you see this, you remember something. So this one, remember this one, integration, the finite one, where you know the upper limit and the lower limit. You get it? All right, so let's move on. So we are saying the total area under the curve is what? 1. The area under the curve is what? 1. And the curve is symmetric. So symmetric, it means it's half, it divided into 2. Whatever is at the left side is equal to whatever is at the right side. You get it? So probability of negative infinity to what? The mu. So here, from this part come like this part is the negative what? Infinity. up to the mu is what? Half of the area. So the area, the total is 1 divided by 2, you get what? Half. And from the mu to what? The positive infinity. You get it? Positive infinity. That one to the area is half. So when you add the two areas, you get what? The number 1. So it's the same thing applies to probability, because we are saying all probabilities are added up to what? 1. So it's between 0 and what? 1. Okay. So let's move on. So they are still on finding normal probabilities. Okay. So what can we say about the distribution of values around the mean? So we are saying there are some general rules. Now, if you move, look at this, the standard deviation. The sigma sign here is the standard deviation. So if you move the standard deviation to the left of the mean and to the right, if you move one standard deviation, so the deviation is here. If you move one standard deviation to the left of the mean and one standard deviation to the right of the mean, the area that is covered under such a curve is mostly about what? 68.26%. So when you decide to move the SD or the standard deviation, one standard deviation to the left or one standard deviation to the right, the area that is covered under such a curve is mostly what? 68.2%. And they are saying they've proven that. You get it? So the same way, when you move the standard deviation or 2 standard deviation to the left and 2 standard deviation to the right from the mean, you get it? The area that is occupied under such a curve is what? 95.44%. So when you move the standard deviation 3 times far from the mean to the left or to the right, that one to the area that is covered under such curve is what? 99.72%. Do you get it? So this one too is a base answer, and they are saying they've proven that one as well. Okay. So they are saying if a value is about 2 or more standard deviation away from the mean in a normal distribution, then it is far from the mean. So when you decide to move 2 or more standard deviation like this one, so it's either 2 or 3, then we are saying the mean, the standard deviation is away from what? I'm listening. Far away from the mean. Are you following? It's like I'm reading. You get to the working part, don't worry. Are you really following? Are you following?
Yeah.
Oh, okay. So if a value is about 2 or more standard deviations away from the mean in a normal distribution, then it is far from the mean. The chance that a value that far or farther away from the mean is highly unlikely, given that particular mean and standard deviation. So when you see a normal distribution and you want to find the probabilities, this is the formula that you're supposed to use. But you're not going to use this one. Our main focus is not this formula. So don't panic, okay? You get it. So we are going to use the standard normal distribution. You get it. So when you see a normal distribution from a question, you have to standardize. You have to convert it from standard normal distribution to a standard normal distribution. You get it. Then you get the z values for you to be able to use the z tables that we have. You get it. Any question up to this place? So we are moving on to the standard normal distribution. So we are saying the standard normal distribution is also known as the Z distribution. So as I said, the Z values. So it has a mean of what? 0. So all the standard normal distributions have a mean of what? They are having a mean of 0 and SD of 1. And they possesses the same probability distribution as the normal. You get it? So let me draw something on the whiteboard. Okay. So that one is Z value. So we are saying every standard deviation, every standard normal distribution is having a mean of what? A mean of what? 0, and a standard deviation, that's the sigma of what? 1. So your mean or your mu is what? 0. And your sigma, that is standard deviation, is what? 1. Do you get it? And they are saying it possesses the same probability as what? The same probability distribution as the normal. So when you see a normal distribution question, you can convert it to what? Standard normal distribution. Then you use the table to solve for it, and that one will become more easier for you. Do you get it? So we are saying values above the mean. So values above the mean. So from the mean is 0. So from 0 going, they are all what? Positive Z values. Do you get it? And the number below the mean or mu. So the mu is 0. So numbers here are all what? Negative Z values. You get it? And above the mu is what? Positive Z values. Do you get it? Right? So let me go back to the slide. So values above the mean have positive Z values. So from 0 going to the right, it is what? Positive Z or Z values. And from below the mean have negative Z values. You get it? From 0 to the left, they are all negative Z values. You get it? So any normal distribution with any mean and a standard deviation combination. So when you see a question, you're having your normal distribution there with mean and standard deviation, can be transformed into what? The standard normal distribution, or Z, through the formula this. So by converting or transforming normal distribution into standard normal distribution, or converting X values into what? Z values, that's what we call the standardization. You get it? So the table was given to us by the what? Z table or something, the Z distribution. So the Z simply talks about the standard normal distribution. You get it? So it's a process of transforming or converting normal distribution variables, that's the X values, towards Z values, is what we call the standardization. You get it? And we are saying standardization helps us to know or identify how many standard deviation is X far away from the mean. Standardization helps us to identify how many SDs, standard deviations, is X far away from what? The mean. You get it? So that is to translate from any normal X to the standard normal, the Z distribution. Subtract the mean of the random variable from the value of X and divide the difference by the standard deviation of the random variable. So this is the formula. So Z is equal to what? X. X is the normal, the standard normal, the normal distribution minus mu, or the mean, which will be given over the standard deviation, which will also be given. Then you begin to standardize. Before you move on to draw your curve for the z values and use the table to find the probabilities under such curve. Do you get it? So this is a question. Let's take a look at it. So we are saying if x is distributed normally with mean of 100 and standard deviation of 50, the z value for x, deviation and standard deviation of 50, the z value for x is equal to 250x. So they are asking us to standardize this particular one. So how do we standardize? He said you subtract your mean from your x, you divide the difference by what? The standard deviation. So here your z will be x. So what's the x here? X is what? 250, right? Minus mu. Mu is what? 100 here. Divided by standard deviation. So the standard deviation is 50. You get it? And the answer here will give us what? 3. So let me illustrate this one on the graph, on the curve. Right. So at first, it was given to us in the x values. Do you get it? So first of all, it was given to us in the x values. And we said the x value, the mean was what? 100. Do you get it? And the x is what? 250. And the standard deviation of what? 50, right? The standard deviation is 50. And we are saying that we can use the same thing here. We can transform it into what? Standard normal distribution. You get it? Standard normal distribution. And by doing so, we are saying all the standard normal distribution, there's mu is what? 0. Every standard normal distribution, the mu is 0. Standard deviation is 1. Do you get it? So by doing so, we got the z value to go at 3.0. So this one becomes our value for z. So it was symmetrical, the line will come. So the first one, it was 50, and after we transform into z value, we got the standard deviation to be 1. You get it? So we are saying the standard deviation helps us to know how many standard deviations is x far away from the mean. So x is what? 250 here. So how many is the standard deviation? That is 50 far away from the mean 100. And it is what? 3 times or something. Yes. Do you get it? So we are saying you can use this z value in place of what? The x value. So you can use the 3 here in place of what? 250 to solve the problem. You can use the 0 as mu in place of what? This 100 here. Do you get it? So any question before we move on to the examples and those tasks? Any question? Ask questions. Do you understand what we are doing? Do you understand? Do you all understand?
Hello.
Yeah.
Yeah, Pabisi.
Charlie.
Pabisi.
Yes,
Hello,
Roland.
can you hear me?
I can hear you talk.
Yeah, I dey talk say at the bank by do there this thing the that table like how we go read the table no that way I know the bab like
Table.
he say he take the figure for year make say 250 yeah
And that one we no reach there,
I
we
mean
no
take
catch
the
there.
figure for you go read for you know which okay
Yeah. We're about to solve questions on that. So with the
okay
table, we are going to use the z values. We will get there. We get there. I don't want us to get ahead of the class. So apart from that, can we move on? All right. I guess everything is fine. Okay. So note that the distribution is the same. So whether it's normal or standard normal, the distribution is the same. Only the scale has what changed. We can express the problem in original unit, that is the normal or x, or in standardized units or z. You get it? So we can use x or z. They are all the same. The distribution is the same, just that the scale has changed. We've standardized it. You get it? So this was a table our friend was talking about. You get it? So we come back to the table. I want us to read something here. Now we are saying some comparison between the x and z. You get it? The x and z. We are saying both are normal distribution. One of them is what? Standardized. So the z is what? Standardized. The x is in its what? Original units. Okay, we can express the problem, as I said already here, we can express the problem in original unit x or in what? Standard unit z. You get it? Right, so let's move on to the table. We are saying entries in the table give the area under the curve to the left of the z value. You get it? So we count the Roland. We are here now. So let's look at the procedure for finding probabilities using the z table. So to find probability that A is less than X less than B when X is distributed normally. So we are saying, first of all, draw the normal curve for the problem in terms of what X. But for me, I would like you to translate X values into Z. That's you standardization. You transform the X or the normal X value into the Z values before you use that Z values to draw the curve. Then after drawing the curve using the Z values, you use the standard normal table to find your probabilities. That is very simple. You get it? So first of all, you translate X values towards Z values. You get it? Then you draw your curve using your Z values. Then use the standard normal table to solve for it. You get it? So we come back to this part. So let me move on to the whiteboard. So let's say if you are giving your values in Z, like Z format. So let's say probability that Z is less than or equal to the number 2. So how are you going to draw this kind of like phenomenon here, this kind of probability that Z is less than or equal to 2? How are you going to draw it on the curve? So we know that this one is represented by Z, it means that it has been standardized. So just go straight and draw your curve. So you know for Z or for Z distribution or for standard normal distribution, the standard deviation is 0 for all of them. And if they are saying Z is less than or equal to 2, where are you going to place our 2? Where are you going to draw our 2? Like on the number
on the left side of the 0.
Come again. Well, I said the numbers above the mean in under the standard deviation. Then standard normal distributions. The number above the mean is having positive Z values, and the number below the mean is having what? Negative Z values. So the number above the mean is moving to the right. Number below the mean is moving to the left. So Z is less than or equal to 2 will be on your right.
Moving to the left.
Right.
Less than or equal to.
And so we are now drawing the 2 on the number line. So it will be this, then the boundary will be here. So under linear inequalities, I told you that when it is less than or equal to, we shade what? Downwards. When it is what? Greater than or equal to, we shade what? Upwards. So this one is less than or equal to 2. Though the straight line is for Z value, but you know that, let me read this one here. Can you see the slide? He said values above the mean have positive Z values. So values above the mean is moving to the what? Right. So the number 2 that was given was above the mean here, because 2 is bigger than what? 0. So you place 2 above the mean. So 2 will be here. You get it? Then values below the mean have negative values. So if they said -2, that one you place it on the left of 0. That one can be here. You get it? Then less than or equal to shade what? Downwards or to the left. But this one is saying Z is what? Less than or equal to the number 2. So you first of all consider the number 2. So the number 2 is here. You trace it up. So the rest is what? Negative. Sorry, not negative. Less than or equal to -2. So are you going to shade to the right side or to the left side?
The left side.
Hello.
Yes, yeah, I'm listening.
Hello.
Yes.
So from what you are saying, the mu is 0, right?
Yeah, for every
So if
standard
it is
deviation.
less than 0, it will come to the left.
I can't hear you.
Okay,
Please.
I'm listening. I said we should, for instance, the mu here is 0.
For every, I'm not saying the mu is 0. The theory is saying that for every standard normal distribution, the mu is 0, standard deviation is 1. So get that for once, you get it. I'm not saying it's 1. The theory is saying that. I'm not saying it's 0. The theory is saying it's 0 because for every standard normal distribution, the standard deviation is 1, and the what? Mu is 0. It's unlike the normal distribution.
Okay.
You get it?
Okay.
All right. So,
okay.
Are you okay with that one? If you have other questions, we can continue. What's your question? So I was saying, they are saying that you should find the probability that z is less than or equal to what? 2. Now, when you are drawing the 2 on the number line or on the curve, you forget about this sign and draw your 2 on the number line, because 2 is bigger than 0. So it will be after 0 on your right. So it will be here. Then you focus on the sign. The sign is saying less than or equal to. So I taught you this in under linear inequalities. So I said, when it is after drawing the line, when it is less than or equal to, you shade downwards. When it is greater than or equal to, you shade what? Upwards. So this one, it was less than or equal to. So you are going to shade to your left. And are you going to shade up to 0 or you continue to infinity? Are you going to shade up to 0 or you continue shading to the left?
You continue shading to the left.
Good. You continue shading to the left because the negative infinity to what? The number positive 2. You get it? So the 2 will be the boundary. Are you okay? Are you okay?
Yes, please.
Yes, please.
Okay. So we should find a probability that z is less than or equal to 2. Then after drawing this, you come back to your table. Let me share the screen. Come back to the table. This is our table. You get it? So we have the z values here, negative, and now the most important thing is that we are saying the table reads to the left of the curve. You get it? So entries in the table give the area under the curve to the left of the z value. So fortunately for us, our shaded area is moving to the left. So we move straight to find the probability for the number 2. Do you get it? So this is how we read it from the table. So this one is the negative ones. Let's move on to the positive. So this is how we read it. Roland.
Yes.
Okay, so this is how we read it. So we are saying that we divide it into 2. So 2 points. So sorry, we are saying that 2 is equal to 2.00, right? Hello.
Yes.
Yeah.
Yes,
Okay.
yes.
So you see that this 0.1 corresponds to what? The 0.00. So this corresponds to this. So when you are looking for 0.1, this should be your probability for that 0.1. The same thing applies to if you are looking for 0.5, it is this one, then 0.00, it's this answer. So this one, we are looking for the probability for 2.0, positive 2.0. So it's 2.0, and the top, you choose 0.00 where they meet. So they meet here. That's a 0.9772. Do you get it? So your probability is that.
Can you go back?
I'm saying that this 0 here corresponds to the 0.00 here. The same 0 here, the same 0.0 here correspond to what? The 0.001 where they meet here. You get it? So for instance, if you are looking for 0.52, this is 0.5, then you move on to find 0.02. 0.02 on the top, you see this one, 0.02. And where it meets with what? 0.5. That one is this one, 0.6985. That one will be your probability for 0.56. Okay, so as I was saying, see, depends on the z value that you get. It's either they will give it to you in the question or they will give you the x values. Then you standardize for you to get the z values before you use what the standard normal table. You get it? So if the number you got is, let's say you got the number to be the z value, you got it to be 0.35, right? And you are looking for that probability on this table. You get it? So we know that 0.35, you expand it. 0.35 is also is the same as 0.30 plus 0.005. Do you get it? Do you agree with me?
Yeah.
All right. Roland, Ahmed, are you okay?
Yeah.
Hope you know 0.35 can be written as this one. 0.30
Plus
plus
0.05 is the
0.05.
same
Yes.
as 0.35. Yeah.
Yes. So when you're looking for the probability, let's say you got the z value to be 0.35, and you are searching for that probability on the table here. You get it? You are going to expand it. You are not going to use 0.35 because you not find it on the table. They will not write 0.35 for you. So on the first column is the z value. You search for 0.3. You expand it. The first one is 0.3. So we look at 0.3. 0.3 is here. 0.3 is here. Do you get it? Plus 0.05. So the next one, the plus, after the plus, that's why when you look on the horizontal side, like on the top. So from left to right, so 0.00, 0.01, 0.02, 0.03, 0.04, 0.05. So you see 0.05 and 0.3. So 0.3 plus 0.05, where they meet. So it's here. They meet here. You get it? So you see 0.05 and 0.3. 0.3 is the same as 0.30 here. Then plus 0.05 is the same as 0.05 here. So their meeting points, we know this in graph, when we are drawing graph, the coordinates, you trace from x-axis and y-axis where they meet, you plot your point there. You get it? So this one, 0.35, when you expand it, it will be 0.30 plus 0.05. So the first one is the z value, that is 0.3, is this one. You look for 0.05, you get it, wherever they meet, that will be your what? Probability. Okay. You understand, or should I go over again? So
Yeah, okay.
0.3 here meets with 0.05 here. So the answer for 0.35, or the probability for z value 0.35, is this 0.6368. Do you get it? You get it?
Yeah.
All right.
Yeah. Thank
You're welcome. So let's look at this one. Hope you remember finite integration, where we have the upper limit and the lower limit. You get it? So we know the starting point and the ending point. So here, always, look at this one, always. probability that A less than or equal to Z less than or equal to B is equal to the probability that Z less than or equal to B. Look at how it is written. Don't change the less than sign. So let me teach you like simple method here. You see that B is bigger than what? A on the number line. So A comes after what? B. So when you see something like this, always probability that A less than or equal to Z less than or equal to B. Now you are looking for the probability under this curve. So you are not looking for the probability, you are looking for the probability between this area, between A and B. So between A here and what? B here. What's the probability? And they are saying when you see something like this, just look for the probability that Z is less than or equal to B. Then you subtract it from Z, probability that Z is less than or equal to what? A. So you first solve for the probability that Z is less than or equal to the biggest one minus probability that Z is less than or equal to what? The smaller one. That will give you the answer between these two. So when you see something like this, probability that, let's say, -1 less than or equal to Z. This, come on. So when you see probability that -1 less than or equal to Z, then Z is also less than or equal to what? The number 2. What you do is just solve for the probability that Z is less than or equal to what? The biggest one. Less than or equal to Z is less than or equal to what? The biggest one, that's the 2. Close it, minus probability that Z is less than or equal to the smaller one, that is the -1. Then you find the probability that Z is less than or equal to 2 on the table, minus P is less than probability of Z less than or equal to -1 on the table. You subtract the smallest from what? The biggest. The smaller one from the bigger one. That one will give you the probability between the area. You get it? So as they've written here, you get it? So as they've written here. So from -infinity up to A and -infinity up to B. So you do the probability from -infinity up to B, you subtract it from you do -infinity up to A, you subtract it from -infinity up to at B, their probabilities. So probability that Z is less than or equal to B minus probability that Z less than or equal to what? A. That one will give you the probability under this curve or between these two, A and B. Any question before I move on to take a typical example? Any question? Any questions? Let's move on fast. We have a lot to do. So if it is okay, just let me know and move on. Can I move on?
Yeah, move on.
Oh, okay. So there's an example here. So they are saying that you should find probability that 0 is less than or equal to, let me copy this one. So this is the question. So you first of all draw a curve for the question given. So this one is already in Z value, so you don't need to standardize. But if it were to be X value, that one supposed to standardize before you draw your curve and find it on what? The table. So all the standard normal distribution, as I said, the mean is what? 0. So mean is 0. So where are we going to place our upper limit and lower limit? So this is the upper one. So it is 2. And we are saying when the Z value is positive, you must record it at the right side of the 0. So it will be here, 2. And the 0 is here already. So the boundary will be what? 0 and what? 2, because we have 0 here and 2 here. So 0 and 2. So the region, the shaded region will be here. You get it? So this will be the area. And we are saying that for you to solve this type of question, just find the probability that Z is less than or equal to 2, that's the bigger one, minus probability that Z is less than or equal to 0. You get it? So that's the clue here. Equal to. So from here, we move on to what? The table. So let's move on to the table. So this is the table. So we are looking for probability that Z is what? Less than or equal to 2. So less than or equal to 2. Just look at the 2. So 2.0 is this one. Do you get it? So 2.0. Can you see the table?
Yes.
Okay. So 2.0 is here. 0.00. So that one will be here. They will meet here. So 0.9772. 0.9772 minus. We then look at the look for the probability that Z is less than or equal to 0. I think that one is 0.5. Yes. So hope you can see the screen. So it is 0, then 0.0. They meet here. So yes, 0.5. You get it. So 0.500 is the same as 0.5. You get it. So that's the answer for this one. 0.4772. You get it. So this will be your probability for what? This area, or the area covered, and the probability for this area. Yes. So between the 0 and 2, that's the probability. You get it. So whenever you have something like, you get something like this, just look at the probability that Z is less than or equal to the bigger one minus Z is less than or equal to what? The smaller one. You get it? That will give you the probability between these two. So this 0.4772 will be your final answer for this part. So every time, just look at these brackets. if you see Z in the middle, then you are good to go. Just look for the probability and solve it. You get it on the table. Look for that probability on the table. But when you see X in the middle here, you have to standardize. But this one, they already they give us this question in what standardized form. But if you are to see X here, you have to standardize it. You have to transform the X value into Z value, transform the normal to a standard normal. You get it before you can use the table, because the table values are given in what? Z. Right. So let's take a question, a different question. So I told this one there, So when you see your question, just transform it to what? Z, or standardize before you draw the curve. Then use the normal table to find it. You get it. So this is, we have a certain example here. We have a question on board. Let's solve that one. So someone should read it for me. Read it for me. Read the question here for me.
Okay, suppose X is normal with mean 8.0 and standard deviation is 5.0. Is it the probability that is? That's the question.
Is that
Suppose X is normal with mean 8.0 and standard deviation is 5.0. Find the probability that 8 is less than X, which is also less than 8.6.
okay? Oh God, they gave us this. Give us the solution. So okay. What do you think the solution will be? How do you think the solution will be?
Yeah, it means for me, I think say sometimes if you change the X to Z values, right?
Yeah, so I said whenever you see X here, you must what? Standardize. You must change it from what? The normal to what? Z. Yeah, the normal. So you move on to our standardize. And for you to be able to standardize, we are having two X values here. So we are having one to be what? 8 and one to be what? 8.6. So we have to standardize all of them. So we have Z1 will be what? So we are saying it is what? The X value. So the X value minus what? Mu. Minus what? Mu. Over what? Sigma. You get it? Over sigma. So X is what? 8. Minus mu is what? 8 from the question. Divided by what? Sigma. The sigma is what? The standard deviation. Standard deviation is what? 5. So what will be the answer? What will be the answer? Oh, guys, be active for me. Let's finish quick. So we have to standardize the second one as well. So Z2. So we know X to be what? The second one is what? 8.6. That's the upper boundary. So 8.6. 8.6 minus what? Mu. The mu is the same as the mean here. Do you get it? So this one to give us. Who is having a calculator? I'm not having a calculator here. Yeah, just punch this one for me. Who is punching it for me? E. Oh, so no one is giving me the answer.
Zero 0.12.
The first one.
Okay, so we now know that probability that 8 less than X less than 8.6 is the same as what you have done here. You standardize it, so it's the same as probability that. So the 8 you standardize it to be what? 0. You get it? Less than or equal to Z. This time around you standardize it, so change the X to what? Z. Less than or equal to the 8.6 to we got what? 0.12. You get it? So from here you use this one. So you find, as I told you, probability that Z is less than or equal to the same. You use the same graph. So 0.12, the bigger one, minus probability that less than what? 0. So from here we use the graph. So equals sign. So what's the probability that Z is less than or equal? Z is less than, this one is strictly less than 0.2. So when you are using the table, less than or equal to, you use the same thing. You get me? So we can say that 0.12 can be written as what? 0.10 plus 0.02. Do you understand? All right. So let's look at 0.12 on the table here. So 0.12, we established that it is equal to 0.1 and 0.02. So here. Do you understand? Do you understand?
Yes, please.
Oh, okay.
Yes.
Okay. From what we did the other time, this one, we know that probability that z is less than or equal to 0, or p is less than 0 is what? 0.5 from the table. So here 0 is here, right? So what will be the answer?
0.0478.
All right, thank you. 0.4.
04.
Okay, 0.478. Okay, so that's the probability. That will be your answer. Okay, that will be your answer for this area. Oh, sorry. I didn't draw the curve for this one. So the curve will be this each. So z is here. We all know that standard is 0. So 0.12 will be here. So the boundaries will be what? The 0 here and what? 0.12 here. So this will be your answer for this area, the probability. Do you get it? This will be your answer. So any question before we pick another question and solve it, for us to solve that question. Who is having a question? Okay, if no question, let's continue. So this is the answer. Okay, I think you can solve this one, the same thing. This one to x is this. So this one, they give you the x. So you just standardize. You convert this 8.6 to what? Your z. So you standardize. So it will be, let me do this one. So it will be x is what? 8.6 minus 8. That's the mean all over what? Standard deviation. That's the 5. So that one will give us 0.12. So we've done this one. Each. All right, so I want us to pick another question for us to solve. So all of this one, you can do it. So this one was given to us in terms of x. So you just have to standardize. You convert this x, you change it to what? Z. So you convert the x here into what? Z. You get it? Then you solve it. And you know how to do this one. Okay. Right, so I want us to solve this question. Okay. Okay, so someone should do this one for me. You draw the curve, you lead me to draw the curve. So probability that Z is less than or equal to 1.56. So we are going to draw this curve and we solve for the probability. All right. So this one was in Z, so there's no need for you to standardize. So we are saying the mean is always 0 for standard normal distribution. The standard deviation is 1. Okay, so this one is Z is less than or equal to 1.56. So this one will be on the right or above the mean. So this one, the 1.56 will be here. So the boundary is this one. And we are saying it's less than or equal to 1.56. So it's right from the negative infinity up towards the number 1.56. So you shade towards the left tail of the curve. You get it? So all the way. You get it? So let's move to the graph. Now we know that 1.56 can be written as what? 1.50 plus what? 0.06. Do you agree?
Yes.
Okay. So 1.5 and 0.06. So let's look at this one on the graph. On the table, sorry. So 1.5 positive is here, right? Then if you here 0.06 is this one. So wherever they meet, so 0.6 vertical, 1.5 horizontal. So 1.5 here, 0.6 here. So they meet here. You get it? They meet 0.9406. Right. So 0.9406. Okay, so that will be your answer. So you see the table given reads to the left of the curve. So if it is less than or equal to, you don't have problem. But okay, so someone should solve this one for me. Probability that Z is less than or equal to what? Minus 1.56. Who can tell me the probability on the table?
I think it's the same, or
This one is negative. Negative 1.56. So negative 1.5, then on top we look at the same 0.06. So here 0.06, wherever it matches with negative. So this one is what? 0.0594. You get it? One may ask, we said the curve is what? A bell shape, is symmetrical. So whatever is the positive side is equal to whatever is what at the negative side. So why is it that the probability that z is equal to z is less than or equal to 1.56 is not the same as z is equal to less than or equal to negative 1.56? You get it? Because when you draw the curve, sorry. Okay, really. So when you draw the curve, so this one is negative number, so it will move to the left or below the mean. So negative 1.56 is here. You get it? So you shade to the what? Left. You get it? So you see that the negative one is covering the smaller part, but the positive one is covering what? The biggest part. That's why we didn't get the same thing. But when you have to subtract, this one, the positive one from the number 1, you get the same as this. You get it? So when you have to find probability that z is greater than or equal to 1.56, it's either you solve for probability that your answer will be 1 minus probability that z is less than or equal to what? 1.56. Or you forget 1 minus the something, then just solve for p into bracket z is negative less than or equal to negative 1.56. Yeah, so let me illustrate that one on the board. Okay, so as I said, they are saying that the thing is what? Symmetrical. So whatever is at the left side is equal to whatever is at the what? Right hand side. So why is it that the same 1.56 positive is giving us different probability, negative is giving us what? Different what? Probability. So let's say if you are giving this, look at the sign. The sign is very important because this one is reading to the left. So the table, we have been told that the table 2 is reading to what? The left side. You get it? So if it is reading to the left side, then you don't have problem. You just read straight from the graph or from the table. You get it? So what if you've been given this probability that z is greater than or equal to, so look at the sign, greater than or equal to 1.56. So this one, this is the mu, 0 here. So 1.56 will be here. You get it? And you trace it. So this one, are you going to shade to the left or to the right? Are you going to shade to the left or to the right? This is the boundary. The boundary is 1.56. So are you going to shade to the left or to the right?
To the right.
The right, good, because it is greater than or equal to. And we have been told that the table given to us, the z values, it's read to the left. It read to the left, you get it. But this one, it is going to the right. And we have been told that the total area under the curve is what? 1. Or all probabilities add up to be what? 1. And if we are looking for this region, why don't we change this greater than or equal to sign to less than or equal to sign and subtract it from 1? So why don't we do it this way? 1 minus probability probability that z is what? Less than or equal to. So the moment we bring 1 minus, it means we can change what? The less greater than or equal to sign here to what? Less than or equal to the same 1.56. So what did we get for positive less than or equal to 1.56? It was what? 0. This one, positive 1, 0.949406. And someone should subtract and give me the answer. I beg on me.
0.0594.
0.0594. Okay, thank you. So I repeat, if you see greater than or equal to, you cannot use the table to do that work. Just change the sign to less than or equal to. Whatever you get, you subtract it from 1. When you are subtracting it from 1, the number given, don't change it. Just change the greater than to what? Less than. Or you can do this. Or you can find the probability that the z given is less than or equal to. I'm coming. So z is less than or equal to what? The negative of that number after the greater than or equal to. The alternative method is that change the greater than to less than, and the number to change it to what? The equal sign, negative sign. So negative 1.56. You get it? So when you change the greater than to less than and the number from positive to negative, it means you are not going to subtract it from 1. And when you search for the probability that z is less than or equal to negative 1.56, we get what? 0.0594, which is the same as the positive 1 subtracted from what? The number 1. Do you understand it?
Yeah.
So let me go over again. As I said when you get a question and the sign in it is what? Greater than. Bear in mind, you cannot use the table because they are saying the table reads to the left and greater than will shade to the right. So whenever you see greater than, just change. You have 2 methods. You can change the greater than to less than. Remain the number to be positive. If it is positive or negative, remain it constant. Then just change the greater than to less than, then subtract it from the number 1. You get the answer. Or you will not subtract anything from 1. Just find the probability that z is less than or equal to. You change the greater than to what? Less than. Then the number given in the question, if it is positive, you make it what? Negative. If it is negative, you make it positive. The answer will be the same. But if the second one confuses you, don't use the second one. Don't try the second one. Always focus on the first one. The first one is simple. Just turn the less than or equal to sign. It is greater than. You turn it to what? Less than. Then you subtract it from the number 1. Or probability that z is less than or equal to. You change the greater than to equal to. Then the number given to, you negate it. This one is positive, so you negate it. And you look for that on the graph. That one, you will not subtract it from 1. You get the same answer. Any question for me? Any question for me?
No, please.
Okay, what about the rest?
No, please.
You said
No.
are you okay? Can I move on? The time is moving fast. Let's finish it so that you can sleep. Are you okay?
Yeah.
Yes, yes.
Okay. So let's solve this one and close. This is an application question. We are going to use a standard normal distribution to solve this one. Okay, so someone should read fast so that we finish it. So who is reading? Volunteers should read it for me.
A warehouse distributor of carpets keeps 6,000 yards of deluxe shag carpets in stock during a month. The average demand for carpet from the stores that purchase from the distributor is 4,500 yards per month, with a standard deviation of 900 yards. What is the probability that a customer's order will not be met during a month? Assume carpet demand is normally distributed. Smith, we can't hear you.
Hey. Okay, sorry. So I said from this question, we know that our X is 6,000 here. Our mean, that is the mean, is the average. Average carpet demand for carpet is what 4,500 yards. 4,500 yards. And the standard deviation is what? 900 yards. You get it? And they are asking, so what is the probability that a customer's order will not be met during a month? Do you get it? So what's the probability that a customer demand will not be met during a month? Now the warehouse distributor is keeping carpets 6,000 yards. Do you get it? So whenever a customer demands, like, a customer demand carpet more than 6,000 yards, that demand won't be met. Do you get me? So the probability will be demand greater than what? 6,000. Do you understand the question?
Yes.
Okay, so we know that they are asking what is the probability that a customer's order will not be met during a month. Assume carpet demand is normally distributed. So we've been able to pinpoint out this. Then we know what to do next. We know what to do, like standardize, right? So Z is equal to what? Our X. So X minus mu all over standard deviation or sigma. So let me write SD, standard deviation. So the Z, X is what? 6,000 from the question. minus what? Mu, 4 times 500. Divided by what? 900 yards. So what will be the value for Z? 1.666.
1.66.
So we just run it to 2 decimal places, 1.67. Do you get it? So now your distance will be probability that Z, so will not be met. So this one is greater than what we are having in the warehouse. So strictly greater than what? 1.67. If it was Z, if it was X, it would be X greater than what? 6,000. But we've transformed this 6,000 into what? 1.67. That's why we call standardization. You get it? So this one is greater than, because if a customer demands 6,500 yards, you cannot what deliver, because what you are having is less than what was asked or what was demanded. If the customer demands 5,000, that one you'll be able to what provide, because you are having 6,000. 4,000 you'll be able to what provide. 3,000 you'll be able to provide. By 6,002 you'll not be able to provide. 7,000 you'll not be able to what provide. So Z as this here. So always the standard deviation for standard normal distribution is what? 0. 1.67 will be here. So you trace what upwards to be the boundary. So this one is greater than. Will we shade to the left or right? Are you going to shade left side or right side? Greater than. So are you going to shade to the left or to the right?
Right side.
Right. Okay.
Right side.
Yes. So the table 2 reads to the what? Left, right?
Yeah.
The table reads to the left. So simple. 1 minus probability that Z, just change this sign to what? Less than 1.67. Do you get it? So 1 minus, we know that 1.672, you can expand it to be, so 1.67 is equal to 1.60 plus 0.07. Do you get it? So we look for 1.6 and 0.07. So let's move straight to the table. Can you see the table now? Yes. So 1.6. 1.6 is here. Is here. Then we look for 0.07. That one too is here. So wherever they meet, 1.6. So it's what? 0.9525. 0.9525. Okay. All right, so just punch this one for me. What will be the answer? What will be the answer? Please, you know that we are come to do quantity, so you guys should have calculator by you. Because I can't be talking and punching it at the same time. I beg you.
0.0475.
Okay.
Thank you, sir. 0.0475. And I said we have other way. You get, so you see that you change this greater than to less than. You subtract it from 1. Or it's the same as by this time. Who is that? All right, so 0. So probability, the same thing is probability that Z here is less than. But this time around, I'm coming. So you change this 1.67 towards negative 1.67. You get it? So first of all, the greater sign you change to less than, and the number positive 2 you change to at negative, but you're not going to subtract it from 1. When you change it to negative, you not subtract it from 1. So let's look at that one. So we are going to look at negative 1.6 and 0.07. So let's look at that one. Negative 1.6. So negative 1.6 is here. Then 0.07. Think here 0.07. Negative 1.67. When it is positive on the top, don't like bother about it. The negative is the z value here. So negative 1.6, 0.07 is this one. 0.0475. Zero. Yes, 0.0475. Is it not the same? Is it not the same? Hello.
Yeah,
Yes. Yes.
It's the same.
So we have 2 methods. So it's either when it is greater than, you apply this when it is what? Greater than. So when it is greater than, just change it to less than and subtract it from the number 1. Or after changing it to less than, the number here, when it is positive as well, you change it to what? Negative. Then you look for that negative number on the graph. So at times exams too, when it is positive like this, they can give you the negative values. You get it? So that one, it depends. You get it? So any question before we end our discussions? So we started with what? Binomial distribution. We ended we came to what? Poisson distribution, hypergeometric, normal distribution, standard normal distribution. So any question for me before we end the class? Any question before we end the class? Hey, any question? Let me